Remember when as a kid solving maths, you calculate the child's age to be older than the father? It seems sometimes scientists also make that kind of mistakes. After all, if the star was really older than the universe and the Big Bang theory had been proven wrong, it would have been a great blunder and you would have heard about that. HD 140283. What? The name sounds boring to you? Let me make it interesting. The star is also known as Methuselah star. As you probably guessed, it's a biblical name. He was the great-great-great-great-grandson of Seth, the child of Adam and Eve, whose lifespan as recorded in Genesis was 969 years, also as the longest lived human. It seems we love to name any old star or planet after Methuselah. This should not be followed, as it creates blunder among the media and they love to spread it as they like. After all, how can a star just 200 light years away be the oldest star in the cosmos? We know the stars which were formed just after the universe was born are the oldest stars, and they are so far that light from those stars has not even reached us yet. This is one of the reasons why we are so excited about James Webb Telescope. It will be able to see those stars. So what's going on here? If you know how stars function, you can look at their physical attributes and calculate their ages to figure out when they were born. As a star ages, it changes in several ways. Its radius, brightness, and temperature all vary as it burns up its fuel. However, a star's lifespan is mostly determined by only two characteristics: its mass and metallicity, which refers to the presence of quantity of elements heavier than hydrogen and helium. The earliest stars we have discovered in the universe are extremely pure, consisting almost entirely of hydrogen and helium leftovers from the Big Bang. Wait a minute, what? But that means Methuselah's star is more than 13 billion years old, specifically 14.5 billion years. And this is a significant issue, given that the universe is just 13.8 billion years old. For the fact, age of Methuselah's star used to be considered 16 billion years, but scientists recalculated and found it to be 14.5 billion years. Still, this makes Methuselah's star about 700 million years older than the universe. As you know, there have been a numerous number of studies to prove the age of the universe to be 13.8 billion years. So, only thing that could be wrong is the age of the star. Though it's always possible that something strange happened in the history of the star that we don't know about. It's likely that it began life as a higher mass star that had its outer layers scraped away, drastically limiting the star's lifespan. It's possible that later in life, the star ingested some material that modified the heavy element composition, skewing our impressions today. It's also feasible that we have made a mistake during the subgiant phase of this elderly, low metallicity star's stellar growth. When calculating the ages of the earliest stars, these unknowns and in some cases unknowables might cause inaccuracies. The issue is reducing the number of unknown factors. Getting the distance is one thing that helps us figure out how bright it really is. We can measure brightness here on Earth and then adjust for distance to figure out how much light is truly radiating, which is termed luminosity. As a result of the recent advancements, a group of astronomers decided to revisit the star. They employed softwares to develop models of how stars evolve over time based on fundamental features such as mass, brightness, elemental content, and so on, which was essential here owing to the star's low metal concentration. Of course, that was the best observation of Methuselah's star till date. So, how old the star really is? 12 billion years. Isn't that better? Comfortably younger than the cosmos and therefore formed after the Big Bang. But obviously, it's still really freaking old. The Sun is 4.6 billion years old for comparison. The Milky Way galaxy itself is about 12 billion years old, meaning this was one of the very first stars to be born in it. Maybe even as the galaxy itself was forming. Is there anything more amazing than that? It's hardly surprising that the star is currently dying. Given its ancient age, it has been running out of hydrogen fuel in its core for a long time and is now expanding into a red giant. That process is still in its early stages, so we refer to it as a subgiant. It's now approximately twice the size of the Sun, and it will expand significantly more in the future. It will go through a protracted process of shredding mass through a subatomic particle wind, shrinking, expanding again, and finally blowing off all of its outer layers to become a low-mass white dwarf. Then it will cool and fade away over the billions of years to become a black dwarf. That will take much longer than it has already lived. Therefore, it has a very, very bright future ahead of it. So, here's another lesson for you. When you find a star that is older than the universe, it proves one thing: you aren't finished studying either one of them. Subscribe and remember, space is the future.